Solid principle is also known as pillar of software development because if you're a software developer, you have got to learn solid principle. Solid principle was first introduced by Robert C. Martin, who is also known as Uncle Bob, and then the abbreviation solid was actually given by Michael Feathers. Solid principle allows programmer to write code that is easier to understand and change later on. For a software, a change can be requested at any time, and any change in a tightly coupled code where classes are highly dependent on each other can break the code. Whereas with Solid, we can write code which is more testable, maintainable, scalable, and reusable. Let's look into the first principle, which is single responsibility principle. Single responsibility principle says that a class should have only one reason to change, meaning a class should have only one job. Let's take a simple real-world example. Let's say you join a team and you are given a multiple responsibility like development, designing, testing, and also product management. In this scenario, you won't be able to do even a single task properly, and this scenario breaks our single responsibility principle. With single responsibility principle, you will be given only one responsibility. That is, either you can be a developer, you can be a designer, or you can be a tester, or you can be a product manager. Means one person should have only one job to do. Similarly, when you write code, one class should have only one job to do. Next is OpenClose Principle, which says that code should be open for extension and closed for modification. We should be able to add new feature to a class without affecting the old code. This is because whenever we edit old code, we run the risk of introducing potential bugs. So if at all possible, we should avoid touching the proven and trustworthy old production code when we are writing a new code. Let's look into a real-world example to understand open-close principle. Let's say you are a travel agent and you have created a package with flights, hotels, and guided tour. And this package is working really good for you. And most of your customers prefer this package. Some of your customers demanded that they need a package with breakfast included, and they don't care about the return flight tickets. So to accommodate those customers, you change your original package, which works for the new customers, but your old customers are not happy anymore. And you end up losing many more customers. As you can see, this is not a good deal for you, and this also breaks our open-close principle as you modified your original package in order to accommodate new changes. To make it work with open-close principle, what you need to do is not to modify the existing package, but add an extension and add an extra facility like breakfast in your package for an extra cost. So this would keep your old customer happy because it did not impact their package, and your new customers can pay extra cost if they want extra facility. And this makes your package closed for modification and open for extension. Now, next principle is Liscope substitution principle. This principle says that a child class should be able to replace its parent class. A very simple example of this would be father-son relation. If a father is a farmer, then his son should know farming as well, and after his father retires, his son can replace him. So with Liscope substitution principle, whenever you are writing a child and parent classes, you have to make sure that child class should be able to replace its parent class. Next is interface segregation principle, which says that many client-specific interfaces are much better than a single interface with many functions. A very simple real-world example would be a restaurant menu. If you're a vegetarian and you are given a menu which contains both veg and non-veg options, then that breaks interface segregation principle. With interface segregation principle, if I'm a vegetarian and my friend is non-vegetarian, we both should be given two different menus. I should get veg menu and my friend should get non-veg menu, and that makes both of us happy because we can easily browse through our menu without any problem. So in the same way, in code, when you write interfaces, make sure to create multiple client-specific interfaces instead of one single interface with a lot of functionality which your client might not require itself. Now the last one is dependency inversion principle, which says when you are writing code, your high-level module should not depend on the low-level module. Both should depend on abstraction. A simple real-world example would be our switchboard. Here our plug is high-level module, and the wiring behind the plug, which actually gets us the electricity, is the low-level module, and our switchboard is abstraction. So our plug, which is the high-level module, does not depend depend on the wire, which are the low-level module. Instead, it depends on the switchboard. So our plug, which is the high-level module, does not depend on the low-level module, which is the wires. So instead of depending on the low-level module, the plug will depend on the abstraction, which is the switchboard. Similarly, in code, our high-level module, such as UI interface, should never depend on the low-level module like database manager or network manager, and both should depend on abstraction or an interface layer. So this was Solid Principle with real-world example. If you like this video, please do subscribe, share it with your friends, and if you think this was too fast for you, then you can take my Solid Principle course on Udemy, where I have explained each in details with real-world and code example. Check out the description of this video to see the discounted link. Thank you so much for watching. Bye-bye.